Hi. In the previous session, you have learnt the definition, classification, and synthesis of few heterocyclic compounds. In this session, you are going to learn the structure and basic properties of pyrrole and pyridine. Okay. Let us discuss the structure of pyrrole. Pyrrole is a 5-membered heterocyclic compound. It contains 4 carbon atoms and 1 nitrogen atom in the ring. So total 5 atoms in the ring. All these atoms are sp2 hybridized. That means each atom has 3 hybridized orbital and the fourth one is unhybridized. Out of the 3 hybrid orbital, 2 of them overlap with each other to form totally 3 Cc sigma bonds and 2 Cn sigma bonds. The third hybridized orbital of each atom overlap with s orbital of hydrogen to form 4 CH and 1 NH sigma bonds. Okay. The fourth unhybridized orbital overlap sideways to form cyclic pi molecular orbital and it is uniformly distributed above and below the plane of the ring. You can see the picture here. Thus, pyrrole is cyclic and planar molecule. Next, whether it is aromatic or not. So, we know that aromatic compounds should satisfy Huckel's rule. Huckel's rule is nothing but aromatic compound must contain 4n plus 2 pi electrons. So here, if you calculate the 4n plus 2 pi electrons for pyrrole, it will come 6. Means 4 electrons from carbon and 1 pi electron pair of nitrogen. So totally 6 electrons. This indicates pyrrole is aromatic. Next, the basicity of pyrrole. We know that compounds containing nitrogen acts as a base. That means pyrrole is basic in nature, but it is a weak base because the lone pair of electron of nitrogen is involved in delocalization and are not available for protonation. However, you can protonate the pyrrole at the ring carbon in acidic medium followed by polymerization. And one more point you have to notice here, that when the ring carbon gets protonated, pyrrole loses its aromatic character. You can see the polymerization step here. Okay. Now, let us discuss the aromaticity of pyridine. Pyridine is a 6-membered heterocyclic compound. It contains 5 carbon atoms and 1 nitrogen atom in the ring. Like pyrrole, in pyridine also, all the 6 carbon atoms are sp2 hybridized. Out of the 3 sp2 hybrid orbitals, 2 of them overlap with each other to form Cc and Cn sigma bonds. The other sp2 hybrid orbital of carbon overlap with the 1s orbital of the hydrogen to form 5 CH sigma bonds. Whereas sp2 hybrid orbital of the nitrogen having lone pair of electron remains unused. Okay, and it lies with the plane of the ring. The unhybridized orbital of 5 carbon atoms and 1 nitrogen atom containing 1 electron each undergo sidewise overlap to form delocalized cyclic pi molecular orbital, and they are uniformly distributed above and below the plane of the ring. You can see the structure. Okay. Next, the basicity of pyridine. Since the lone pair of electron of nitrogen is not involved in the resonance, it is freely available for protonation and it forms salts with inorganic acid. See the equation here. Okay. So pyridine undergo protonation to form pyridinium ion. Got it? So if you compare the basicity of pyridine with pyrrole and aliphatic tertiary amines, Pyridine is stronger base than pyrrole but weaker than aliphatic tertiary amines. Here you know the answer. Why pyridine is stronger base than pyrrole? The answer is in pyridine, lone pair of electron of nitrogen are freely available for protonation, whereas in the pyrrole they are involved in the resonance. Okay, that you know. Thus, pyridine is strong base than pyrrole. But then next question, why pyridine is weak base than aliphatic tertiary amine? This is because in aliphatic tertiary amine, unshared pair of electron of nitrogen are in sp3 hybrid orbital, whereas in pyridine they are in sp2 hybrid orbital. You know that electrons in sp2 orbitals are held more tightly by the nucleus than those in sp3 orbital. Hence, pyridine is weak base than aliphatic tertiary amine. Okay. Suppose if you want to compare with aryl amine, you can observe comparable basicity, means not much difference. This is due to the electron withdrawing inductive effect of the benzene ring. Got it? For more information, you can refer these textbooks. Thank you.